I don't know if I want to answer that question.
What's the question?
How often do I play billiards? Now this feels better. So this is...
Can you explain what ringing actually is?
Is there ASMR for smelling? But
No, don't show
you say never touch a running system. It's been like this for 6 years, so no, it does work. If you never had an optical flat in your hands, here's your chance. So you got all your fingers away. So this is very well organized, as you can see. I have no idea where to start here, but welcome to the shop tour, all of you interested people here. So we're standing right in front of the company that is housing the Minuteman machine, and we're located in Eitorf, like in the south of North Rhine-Westphalia, big picture in Western Germany. And we're kind of like in the parking area, and this is also where like the KUKA robot lives. There has been a video, maybe you come up here with the camera so there are not people in the way, thanks. Yeah, this has been like the 6-axis KUKA robot. I bought it, or more I would say I saved it from being scrapped. And there was like the mainboard battery died, I didn't have any parameters on it, and it sat here for 1.5 years. And then apparently also Julian came up with the idea of putting solar panels on top of it. And then maybe you all want to come a bit closer. So then basically it doesn't make that much sense if you want to produce electricity to have the original controller hooked up. Even just the fans would have made power consumption bigger than what it actually yields. So that's why there's a small switching cabinet down there, which is housing an ESP32. That is connecting to my company's Wi-Fi, getting the actual date and time. And then there's a database behind it that tells the controller what time it is and where the sun is actually located. So there are no active sensors seeing where sun is, it just follows stupidly the blind path. And as you heard now, this is like moving roughly for 1 second every minute, so that's why the power consumption is really low on that. And actually you can see it in the video. Don't want to take it apart right now, but this is basically the housing. I put on the existing A1 motor, and there is a stepper that is connected to a gearbox. I think it's 1:180 reduction, and then there's a big crown gear which is also 1:20 reduction. So this should have come down to 1:3600 gear reduction. So
crown gear from the factory?
Yeah, right. I'm just adapting. Basically this is the servo that is also for the A1 axis, but A1 is a bit bigger. And it has a like 12mm hex in the end, and I adapted the servo to it, and basically I'm just hijacking the rotor shaft, and then again I'm by applying 24 volts, and this is what you hear maybe in a few seconds. This is the brake locking and unlocking. So I'm just going to unlock the brake, move for a certain kind of degree that is being figured out by the software, and then the brake closes again for like safety reasons.
What about rain? What about weather?
So it's been sitting here for 1.5 years now. This was another cycle of it moving just for a tiny bit. I gave it some rust protection, like an oil film or something, but you can see here it has been rough on it. It's been 2 winters that it's been out here, but I think I didn't do any maintenance on this machine. And as you can see, this paint is getting a bit blurred out, and there's some chipping on the paint on the motors, but I think for what this robot is actually. I mean, it's a very fun sign outside of the company, I guess, and triggers a lot of things I do on a daily basis, I guess. So I will see how far I can have that run here. I guess if I do some maintenance every now and then and get some new lubrication or oil on here, it will be for some time, I guess. Yeah, and this is like a 600 watt panel on top, according to the old German balcony power plant law. Nowadays you could put 800 watts on top, but yeah, this is what was legal at the time. So I would have used, I would have had a lot of other ideas doing some kind of stuff with this robot, but this, I bought it like blindfolded, and the actual controller that is on here is the KRC1. That's the first gen of 6-axis controllers done by KUKA, and this is all being done in proprietary servo drives, etc. And it's also Windows 95 based, and as I said, there were like parameters lost. If this would have been a KRC2 controller, I would have maybe have done something else out of it. Maybe did like something 3D printing with concrete or whatnot. But since this is way too, the base is just wrong for doing anything intelligent on that platform. So that's why, yeah, I'm not going to do that. So I think it's time to go inside. Can you see on the camera? It's basically, I don't know. Yeah, so basically this company is divided into the upper and lower floor. And down here is everything that is doing dust and chips and is loud and grinding, etc. So all of the dust settles down here and it can just sweep it off, while on the upper floor everything is like rinsing down, and this is more for stuff of methods and 3D printing and electronics, etc. And yeah, this is kind of the central area workbench, I guess. So a lot of the workbenches you will see here, I mean all of them are pretty much self-built, but you will see this 120 by 120 box tubing all around these, because I got them on a yard sale pretty cheap and in a quantity of, I don't know, 30 or 40 meters. And that's why basically everything is built out of these as a baseline for workbenches. And this is really, really sturdy. There's 2mm sheets of steel put on top, and I've no real idea. These have got to be like 200 something kilograms. You can bang on these all day with a hammer. I also added some like this bench arbor press on top of it, and yeah, it's kind of the main area I'm focusing on a daily basis. It also has some quite unique features, like I added this desk here to extend the area of work a bit, and down there there's my grinding stuff for different applications, and this is my, it's also been in a video of mine, the induction heater for putting end mills into the appropriate holders. And this is basically just a giant 84 volt power supply bolted to a induction heater, and that way I can like get the end mills in and out of there. It gets used more than you might think. This is kind of like pneumatic stuff, all the fittings you might need, but there are 2 more drawers, but you can't have really enough of that. But it already extends, but yeah, you never have what you actually need. And then there's also a video about my storage solution. This is like the giant, I don't know, it's not a drawer, how do you call it, whatever. I just picked it up from the trash of the industrial complex I'm in. And these were like bolted down to individual pieces, and yeah, this is what I could like scramble together from all that, and gave it a power wash and yeah, put on some, I don't know, clear vanish to make it kind of look nice. And this is like my storage solution for all the nitty-gritty things you need on a daily basis, like all stuff for woodworking and different kind of machines, handheld tools, from nails to fittings to accessories for all the grinding appliances, etc. If you want to take a look in here, this is basically my screw cabinet. It's a collection of yeah, I don't know where I got all of these from, but essentially you have here what you need in from M3 to M12, I guess, and some fine threaded stuff, etc. Let's take this route. You guys come over there from the workbench. This is kind of like, right now I'm involved in a lot of projects industry-wise. Most of them, I had to remove some of them that I'm not able to talk about entirely, but this is kind of stuff we're getting away with without showing the details. So I, as a company, do prototyping in various fields, and yeah, part of it is like plastic extrusion industry, and then there's food industry, packaging solutions. We can have a look at a robot for packaging applications later on the upper floor. So this is basically all just stuff where yeah, I'm doing here on a daily basis, but it's really hard to put this in perspective because yeah, I don't really sit in any niche. There is working with wood on Mondays, and maybe there's work on titanium on Tuesdays. So I don't really have small words for putting this all together and what I do here on a daily basis.
Is this a die?
This.
For sheet crushing or like some injection?
Yeah, this is basically for plastic extrusion industry, and this is what would call a wide slit nozzle, I guess. So they tend to be around up to 3 meters in size, and they basically have an inlet at the back where, like, usually a granulate-based extruder is pumping the polymers into that, and then there's a certain geometry that spreads out the material into this wide format, and the actual geometry behind it is in a way built that you have an even amount of pressure at the lip at the front, so it spreads evenly. And this is a very small one, I guess. As I said, they grow up to 3 meters or something.
Maybe next time repeat the question they asked, so it's sure.
Sure, will do.
They have like interface, electronic interface at the back. Do you know why that is?
So the question was regarding the electrical supply at the back. This is mostly for heating. It's basically the same as your 3D printer hot end. It has heating elements and a thermistor or some kind of, yeah, that runs a PID loop in the background. But these are like at the extreme end of it, because you have very high thermal mass and very high power density. So everything is kind of very laggy in terms of the response of the system. And as I said, this is a kind of small one. Should we have a look at the metrology area? Who's into fancy measurement stuff?
Fuck yes. Yeah.
All right, then let's do a draw to a table here.
Yeah.
So this is a collection of micrometers, and we'll put. I mean, this is the Metrology standard one from 0 to, I guess, 150, 175 or something. And I do have the bigger ones up to, I guess, 400. Yeah, danke.
Like plastic. Should that be still up there?
No, that is just a knockoff one. I don't mind that. So this is the bigger one, or I guess the biggest one I got. This is up to 300 mil. And then there's your gauge blocks. This is the biggest set I own. This is also Mitutoyo, and
Are they ringable?
Yeah, sure.
Yeah.
Most of them, I guess. I mean, this.
Is it ceramics?
Yeah, this is ceramics.
Why do you use ceramics and why do you use like normal?
Well, usually you would use the ceramic ones for reference purposes because those are really stable in terms of temperature change, etc. And also they are even more resistant to wear than the others. But truth be told, these are none of them were bought new. Essentially, everything you see here is not out of the catalog. It's been bought by myself and then restored in some way or the other. And yeah, so these are my go-to solution for just doing stuff in the workshop. And if I really have to bang these out, but then again, I don't have any measurement protocol over any of these. So the variation may be in the last digit of microns, but for what I do here, that's I wouldn't say plenty good, but most of the stuff I do is then hand fitted or lapped together, where real measurements don't really make the difference. It has to mate each other and don't go into space, and then you have to put it in space in some location, and it has to fit there. I do have both mating parts in the. We can do a test of ringing.
To which?
Just up to the micron, I guess.
Yeah, but your mill has the capability and has enough rigidity to have like.
This is the camera factor, and also not all of them. Yeah, this one has kind of been slightly abused. And I should be wearing gloves, and there are really.
Your fingerprint again?
Really
Your
intricate.
fingerprints with your fingerprints.
Yeah, right. So this was the 10mm one that is obviously one of the most used. Let me see if this. This feels better. So this is.
Can you explain what ringing actually is?
Well, can somebody else? There's been multiple theories on why that is. So some of them say this is because of kind of you create a vacuum between these two surfaces because you kind of like push all the air out. Then some others say the atoms are getting so small in such a small distance to each other that the forces are actually attracting. So there are different theories around it. I have no idea if there's like a consensus in why that is, but all we know it works. Yeah, let's do that at a later point. I'm going to show you around later on. So this.
Do you have a like dent for your micrometers?
No, unfortunately not. I sometimes use like a smaller vise to hold that in here, but I don't have a sophisticated one.
I know there is a 3D printable model online.
Yeah? I should totally do that. It's like the indexable or movable.
Yeah, movable head.
Oh, okay. I should do that. Well, next drawer is also a lot of like gauge pins. You saw that in one of those episodes. Let me give it for a quick second. So this is basically a lot of stuff with dial indicators, and we get that on the table right now. So these are gauge pins. I used like the 195-ish one to get the hot end aligned to each other because this was the 2mm channels I drilled in there. Then we have a bunch of dial indicators. So these are probably the most expensive and accurate one. This is a Micron Tisa. This is, I guess it's Chinese brand, but also Micron range. And then just your standard, this is also a Tisa 10 micron, and like your standard shop tools for doing stuff like that. Then there's various tools for like thread mics if you want to measure threads with most of the accessories, I guess. Of course, you need everything in different sizes. You never have enough.
Draws are deep.
Yeah. And this is, I have no real idea how you call these.
It's an internal
bore gauge.
Bore gauge, yeah.
Bore gauge, thank you. So basically you have, this one does not fit. You put those in here, preload them a bit, and then you have varying sizes of tips you can put on here. And basically this will let me see if I have a fitting one. So basically this would be the gauge to set these. This is the standard. This is to 55 millimeters. Then you would pick your whatever is 55-ish. I think it's this one. This would screw in here. Then you can set this all together, and when you like rock it to the max point, you can twist the dial up here to set it to 0 basically, and then it measures a very small distance in both ways, like let's say 0.5 millimeter or something. It's for finishing passes on anything you do internally. And of course you need those in all kinds of ranges. This is from 18 to 35, this is from 35 to 60, and this goes up all the way because this has extensions. I think some of them I built myself, and I guess you can go up to 200 millimeters of internal boring. So this next draw is basically go no-go type of stuff, and then there's I mean, don't really have a look at how they're dangled in here. I'm kind of pulling that out with a bit of care, but it turns out it works for me and the things I do with it. And there are like gauges for whatever threads you want to like set up on the measurement. There is go no-go, a lot of stuff also for threads. Like I got somewhere from M3 to, I don't know what the biggest one is. This is M35. There you see M50. Basically, whenever you need something for a job, you get that somewhere, I guess. This is like one of the biggest standards for calibration. I got this is 110 mil diameter. Yeah, don't let me get involved into calipers because there's so much to talk about. This is like the biggest one I own. This is 1 meter. I think it's from the Garant store. To be honest, I didn't buy that new either, but yeah, it's kind of in a really good condition. And then over the workshop, I got like 10 to 15 calipers. Maybe just hold on for a second. I get the two most important ones. So my daily driver for just going in the shop is the Mitutoyo Digimatic. This has been working flawless for like 6 years or something. I guess this is well known, and I absolutely love this thing. Before that, and for really advanced caliper measurements, I tend to use this dial one by Mitutoyo. This is 505-666, and what I think exactly. And what I think, if you really want to go with a caliper for whatever reason, this is the way to go for accurate measurements. Because if you have this and a set of gauge blocks, I'm pretty confident in measuring 2 to 3 microns with this. You can't do that with a standard one because you don't have any idea if the tendency is above or below that value it shows. You can see that with this one, and by this thumb screw here, you have a really nice feel on how much tension you put on the measurement. Okay, so we did talk a little bit about precision levels. This is the least accurate I have. This is 1/10 of a mil over a meter.
0.3.
Yeah? Okay.
Why precision levels?
Yeah. But you would start with leveling the machine in the first place. So the question was, why do you need precision scales for machining? For most of cases you don't do, except for you setting up a part that has no reference features. But then you set up the machine in the first place, and that's why you might need this one. This is 400th of a millimeter per meter. And then there's this square, which is arguably in the worst condition of all of those. It needs to be seriously tuned. But this is 200th of a mil per meter, and then also squarish. I just picked that up. Yeah, I have no idea about the real condition. I mean, for most of the stuff you do, but if you would rely that your measurement is perfect, you wouldn't use a flea market version of that. But this was like 30 or 40 euros or something. You can't, I can't leave that on the flea market for that kind of price. So I own only the few that are out of the paper and the wax are actually used. This was pretty much unused before. This is the 60-degree one, and just with your standard gauge block collection, you can set up pretty much any angle on this really precisely. Sine bar. I mean, it's obviously also not in the greatest condition. It has been used. But this is over, what is it, 250 millimeters, 200, somewhere in that range. Yeah? And then maybe, I mean, I don't own any accessories to it. I don't have like monochromatic light source or something, but if you never had an optical flat in your hands, here's your chance.
I did, but what's the job of this?
You can have, does somebody else want to explain it?
So it's just a very flat piece of glass, and you...
Wait, give me 1 second and just...
So it's a very flat piece of glass. You shine a monochromatic light on it and you put it on a surface, usually a lapped surface.
What is a monomer?
A light that only has one wavelength. So what happens is there's a thin layer of air between your part and this flat, and you can see the interference patterns of the glass and the reflection. And if those are nice and parallel, you know that both surfaces are a similar surface. So
Surface roughness?
no, surface flatness.
Okay.
You can only do this with already very reflective parts. So if your surface is concave or convex, you get like circles rather than lines, or like bowed lines, and so you can assess the surface flatness of a part this way to few nanometers, 100 nanometers. Right.
Yeah, couldn't have explained that better.
Do you have a laser? Laser pointer? This is monochromatic light.
Not a very good monochromatic light. Also, you would need to diffuse it.
Yeah, but diffusion's not that bad.
I hate to say no, but I don't have that here.
I have an optical flat at home, and I still haven't used it because I haven't gotten it to work. Maybe either my gauge blocks aren't shiny enough, or my light wasn't good enough, or it wasn't dark enough, but I haven't gotten it to work yet.
Okay, so maybe the last thing that is worth mentioning while we're at it is kind of, I have no idea where the second one is, but this is kind of a large beam coming from a coordinate measurement machine as well. So I use this is like 2 meters 20 or whatever. I can use this for really precise measurements over long structures. So basically there is somewhere a little brother, maybe that is lent to someone, that I can put like on a lathe bed, have it on their bezel point so it is as straight as possible, and then run an indicator on top of it, and it basically tells you a lot about the flatness of the bed you're working with. Yeah, exactly.
Have you tested have you calculated the deflection from its own weight?
No, I haven't. But if you get in this kind of areas, then well, if you're searching for like a used lathe, better leave that out of the equation. It is complicated enough.
Is this aluminium or steel?
No, this is steel.
Okay, because it's shiny.
Yeah, and the other one is like this high and has a cross section of like 50 by 50 millimeters. So it's way more handy. This one is kind of big guy.
That way.
I have no idea. Probably this is like 7-8 millimeters of wall thickness. So this will be, I don't know, 40, 50, 60 kilograms, somewhere in that neighborhood. Maybe a bit less, but I don't know, somewhere there. So then, like, moving on from metrology, we're going to go into essentially manipulating metals, I guess. So this is like a quite old but trusty 40 bandsaw, capacity of around 300 millimeters. That is running kind of rough, but doing its job all the way. I think over the course of the last 8 years, I have used 3 of these cutting blades. They're like really reliable, and even though I don't use any coolant on this machine, it just runs and runs and runs. And well, then there are 3 machines which are actually lended by someone, or he just gave up its shop and doesn't know if we want to continue. Shout out to Noah in that regard. And this is the press brake, this is called, I guess, for bending materials. So basically you can put your sheet metal in there, clamp this whole thing, and then you can like bend this to some angle you want to have. This one is landed, as well as the shear. This is pretty special. I would like to do some things to it, but as soon as I do these, Noah will probably have the machine back. So this is with Ghetto Lightning. So you got all your fingers away. Yeah, it goes up to like in normal steel, like 1.5 mil, and stainless maybe 1 mil. And yeah, it's quite handy for cutting stuff like rubber, PMMA, or any kind of sheet metal, I guess. And its capacity is around 1 meter. Yeah. Okay. In terms of materials, as I said, I do work in a lot of materials. This is mostly aluminum. Then there is plastics, copper, brass, stainless steel. Moving on, this is mostly box sections up there from 20, 30, 40, 45, 50, something like that. So the bigger ones actually do slide into each other, and you can like do really non-precise linear guides or something. Right in the middle, this is basically steel in various alloys. And then on the bottom here, this is mostly tool steel I use for plastic extrusion industry. Miscellaneous stuff of some sort. There's a import cheap hydraulic press, but this works for the stuff I do. Kind of okay-ish. I don't need much more in that regard. Then we got another bandsaw here. This is the vertical one, and this is a Mössner record. It's the 420 type, and I haven't opened this up. Oh, I haven't opened this up in quite some time.
And this is for the...
Yeah, I know. I'm just banging all my... Yeah, whatever. But essentially, this will be with covered with a lot of sawdust from Ranger materials. I actually do cut pretty much anything on here. And this is really handy for just making some kind of a slot into whatever kind of material, or just chopping it off or whatsoever. This is one of the most used machines here in this shop. Okay, moving on. This is collection of welding stuff. So this is I wouldn't do that probably. This could be dirty in some way or the other. Ganz kurz, Micmac ist im Englischen.
Micmac. It's Mick.
Seriously?
Yeah.
Ja. Tick und Big ist der Unterschied.
Ja, genau, den habe ich im Kopf. Okay, so basically this is my go-to solution for doing all of steel work, just basically building framing or something. That's a Micmac combination. But I'm mostly using the MIC component, so with argon and CO2 gas. This is a plasma cutter, 60 amps, which is good for like 16 to 20 millimeters depending on material. And this is my kind of like the oldest welding equipment I own. This is a TIG machine. This has pure argon as shielding gas, and this will do aluminum, steel, and maybe also brazing in brass or something. Behind you there is one of the latest additions I got in the shop. This is a welding table, 3 by 1 meters. And this is considerably flat, but not excessive because it has been used and I'm using it as well, but this is like 1300 kilograms of cast iron. Cast iron has the big advantage of not any like of the small boogers actually sticking to the metal. And this works also pretty well for just having the scribe on here or putting a dial indicator on top. This has been becoming one of my go-to workbenches here for all kinds of stuff. That is working really, really good.
Let me ask you a question. This machine right there, is this like for continuous sheet bending?
Yeah, you can do round bending.
Sharp corners, and there you go. Like.
Yeah, exactly. You can basically put in sheet metal in here, and since you got 3 rollers, by adjusting the middle one, you can set a radius, and then by continuously cranking, you can basically do tubes or cylinders or even cones. This will. You can set this off center, and then you can do cone work. But I rarely use this one. This is also Noah's machine. Maybe let's go this way. This is kind of like another aisle for quick mechanical works. This is a Alzmetall drill press. This is one of the very first machines. We had these for like 20 years in our home garage. Basically, my dad bought it, and I could use that over here as well. So I took it with me. No one really needs that kind big of a drill press at home. And yeah, then we got some grinders of various types. This is like your standard aluminum oxide wheels. Then I got some like emery cloth based. And this is a cup wheel with a diamond embedded into it. So for, I don't know, sharpening end mills and carbide drills or something like that. And then this has been used quite a lot over the last time. It's a combination of a belt grinder and what is it called? Disc grinder, yeah. Especially this part, because it's completely flat, is like being used on a day-to-day basis. So this, I like this machine a lot. I mean, probably this is more like designed for wood, and I'm pushing it really hard with the materials, but it's holding up for like 3 years now, and yeah, kind of like that machine.
Do you regrind your end mills?
No, I don't do end mill grinding, not freehand, but usually I like tooling for the lathe or something, resharpen that, or just do when you do like a relief on the face of a drill, the split point relief, I do that on that cup as well, because it's like very fine radii and you don't end up with wearing that out too fast. You probably won't see that much of it, but this is a flat grinder. It's a surface grinder. This has been like here with my personal stuff embedded, but it gets also used quite a bit. And this is like capacity of 600 mil by, I guess, 250 or something. This is an old Russian machine. It's a Stanko. Let's call it Stanko. and it has been quite reliable as well. It may hold tolerance of, let's say, 2 or 3 microns around this surface, but this all depends on if I do regrinding for the temperature conditions that are just now, then it will probably will be closer. But yeah, it changes because it's sitting right at the entrance, etc. So if I really have to go micron level, it's going to be lap pin anyways, and this is really good for working up to a few microns of that target.
It's good. Your eyes. It's your eyes.
Okay, just a quick heads up. This machine is live. There's no clutch, etc. I don't have to tell you that don't touch anything or buttons or something. You don't know exactly what they're doing. You probably just don't be pushing any buttons at all. So, okay, we find ourselves at the lathe, at the conventional lathe area, and we want to do a part together. So this is basically just a stainless steel. This is free cutting 1.4305 stainless steel, and we're going to do another one of those. This is for a machine I planned, and this is some kind of a bearing situation. This will run in a water tank in a plastic bearing. And since we're doing 20 of those, it is kind of the same time if I do it on the conventional lathe than rather than having the CNC set up, because the CNC, as you will later see, is more for like fine and small stuff. And we can take heavy cuts on here. As you see, I've not touched that and left the last part for you guys. So this is basically, I already did operation 1, which is just having that in the chuck here and turning this diameter, which is kind of precise, and now we're flipping it. And in terms of when I do conventional lathe work, I tend to do it sequentially. So I'm not going to go ahead and put this in and run through 3 or 4 tools and yeah, basically have offsets each and every time, reset it. I go ahead and do the roughing and leave this tool in, just go bang, 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 one after the other. And also that means the parts have time to cool down and to make like tight tolerance as possible.
Do you like make one complete part before doing the series to see if your plan works?
Sometimes, in this case not. So this is pretty basic. This is a lot of material removal, but there's no complicated stuff in here. But I think it is a great opportunity to show some big cutting action. This is triangular insert and a really sharp one, not being coated. And we can go to quite high cutting depths on this part. So let me get this in here. So just for point of reference, this is a Vipered general purpose lathe. It is built in 1960 and I own it for like 12 years now. And it's been one of the most reliable machines I have ever owned. And there are a few things that are not working perfectly, but every time I turn this machine on, it so works in some way or the other. Exactly. I hope I didn't jinx it now. But we're gonna do, I take this radially and not plunge in like this.
Facing.
When we're not facing.
Facing is like that and turning is like that.
Okay, so we're gonna do turning instead of facing because this makes more sense for this kind of part. This will be a 10mm cut, so 5mm depth of cut per side. For the first 2 cuts, we're gonna run it at 450.
What's your feed?
You will see, I have no idea. I'm just gonna go by experience at that point.
Just speak roughly. Like that's and not like it's, yeah.
So as you can see, it is kind of bit wobbly. That's because I have like 1mm of allowance still on the part. And I'm gonna rebore those soft jaws before we do the finishing diameter, so everything runs true. Yeah, so we're gonna go 10mm. Let me check if something... It's a rather fine feed. If I had to guess, it's like 600-700th per revolution or something. But this gives me a very controlled chip evacuation, and I don't have stuff flying everywhere. Like these ones are from a normal C-type. They are everywhere, and this just loads up pretty nicely. So in the last two cuts, the next one is going to be at 710, and the one after that is 900 RPM. These will sound a bit more rough, but also this insert has already done 19 of those dry, so it could be a bit more pleasant cut. And I'm going down with the feed rate just a tiny bit.
I don't know why, but it even smells hot.
Is there ASMR for smelling? So and the last one at 900. So, and trust me, this is way faster doing that on the conventional lathe, where I can use all the horsepower and torque instead of doing that on a machine that is designed to run 5K RPMs instead of having this proper gearbox at the right place. And now the other parts are cooled, and I just put in a finishing tool, put all of them one after another in the soft jaws and just do the finishing pass, and then I have 20 good parts if everything goes to plan. Just to round this up, this is the wipered machine. This, on the other hand, is the toss lathe.
The one that you dropped?
Yeah, the one that I dropped, exactly. It's not plugged in right now. But well, actually, I was transporting it on 4 casters, and one of them got stuck in one of these holes, and basically it was just resting on 3 points, and then was thinking for a time, should I fall not? And then it just made one hell of a noise. But it did end up falling to the back side, and the housing really did absorb a lot of that energy. So I got away with it. Nothing changed in terms of geometrics, but it was like a sad day for me. But we got it up eventually with 2 forklifts, and yeah. All in this small area. This lathe was exactly where it is today. Yeah, this is a lot bigger lathe. I mean, not a lot, but this has a maximum turning diameter of like 420, 425. And this is around, yeah, kind of. This is 500 millimeters on the chuck side, and 1.5 meters between centers. The wiper is 1 meter between centers. And this has some comfort things like a proper housing that can be put right next to the place you want to have it. This is all one size up. This has MK5 Morse taper on the tailstock. This has MK4. This has got a bit more horsepower even, and while this is like capped at 1400 RPM, this is like going up to almost 2.5K. And I'm using that quite often because I do have 2 3-jaw, 2 4-jaw, individual 4-jaw and a collet chuck for this machine. And what are you pointing at? Exactly. And yeah, so this machine is a lot safer to use if you want to do whatever. The chips don't fly everywhere. So this is my go-to solution. This has most of the time the 4-jaw chuck installed for one-offs. And this one has just the 4 cards, it's a 250mm 3-jaw. This is basically for just putting your standard stuff in, just, I don't know, parting something off, turning a radius or something.
So let's talk for a brief second about this lathe and our today's video sponsor, which is PCBWay. So this TOS lathe is great, but what it lacks is some proper handles on those wheels. So what I built as a prototype are these guys, which can be mounted on top of here and work great. But if you use a lathe on a regular basis, these parts won't hold up the demands of an industrial application. I uploaded these same exact parts after PCBWay and had them printed in solid aluminum. Now I'm just gonna transfer these off-the-shelf parts to these SLM printed ones and fit them right back on the machine. We now do have some very stout attachment to our handles. Acquiring parts from PCBWay is pretty easy. You just hop on the PCBWay website, upload your files in whatever formats you got on hand, select the desired materials, and hit submit. You will get an instant quote, and if something's wrong with your parts, an engineer will contact you and find a solution together. Again and again, I'm pretty impressed with the quality of PCBWay and also the time needed for delivery. So check out the video description, there is the first link where you can get a small discount on your first order. Thank you again PCBWay for sponsoring that content. Let's go back to the video.
And yeah, we can have a quick look in the drawers. So this is very well organized, as you can see. I literally didn't do any cleaning before, and so I want you to give like the raw experience how this shop's being run here.
Gridfinity ones?
Yeah, Gridfinity would be a smart thing to do, but yeah, project, what was I counting? 1030 or something. This collection of all sorts of outside turning. This for knurling. Yeah. This is radii. If you just want to have a quick R3 concave or convex, you're just going to grab those, put it in the holder, and you're off to the races. And this is left hand, right hand side tooling, parting, the most various type of negative, positive or neutral geometries, and I have like inserts for most of them. Yeah, next drawer is everything inside, because but a lot of stuff's already in the machine, so this is just the rest of it. This is like for face grooving insert. Yeah, yeah, exactly, trepanning. This is most of the stuff, that all accessories for the 4-cart, 3-jaw chuck. A lot of soft jaws, I use them on a daily basis. For various kind of diameters, on this machine I had a lot of like 350+ diameter stuff on here. This is all Morse taper related, running centers, dead centers, reductions, some drill chucks. And this is just miscellaneous stuff down there, stuff for the machine. Then in this side, this is all about drilling, tapping, inside, outside threads. So this is up to, I guess, 10mm. And then this works up in drill sizes and various high-speed steel tooling.
This is thread?
Yeah, this is M34 by 1.5. And yeah, this goes up to, I think the biggest drill I use on a regular basis is 48mm. This is often being used just as a pilot hole to then just do some work. Most of the work internally I do is around 125 to 150mm, so that gets used quite often. And then there's a lot of drawers with reamers. I think I don't use them too often, but the biggest one I guess is somewhere in the 62 range. So kind of big ass ones. Yeah, sure.
And are they like fixtured on here because I see a thread?
They're interchangeable, I guess. So you could basically have just one standard taper side, and then you can screw on a lot of different options on there. And then there's not much in here. It's just some tab holders. Thank you. So yeah, that's basically the part of lathe tooling. I use multi-fix B on both of these machines, and I have an adapter plate ground, so both share the same center height. So I can use them from one machine to another. And yeah, I need some more multi-fix holders, but who doesn't? So okay. I think we can go on. I don't really... Well, we can have a really short look in here. It's like the rest of the company, as everyone would have it in some way or the other. This is compressors. This is a membrane type compressor, which is being used on a day-to-day basis because it doesn't rely on oil being at working temperature. While this, in contrast, this is a screw type compressor, which is way more efficient and quieter in operation, but this doesn't like being just fed with cold oil all the time, and it will actually throw out a lot of oil in the cooling media afterwards, or the compressed air. And especially with stuff like measurement machines, etc., you don't want to have that. And yeah, this is kind of, when I need a lot of air, I use this one, and just for having some kind of working pressure on the system, I use this one. No, I just unplugged those. There is a, how's it called? A ring. Yeah, an airline supporting all of the shop and also the upper floor. And I just plug in whatever tank I'm using. Okay, then I think we'll see if that works. Last week I did a lot of maintenance on this machine. I had to take apart all of the revolver on this CNC lathe because actually when I did turning operations that created a lot of torque on the tool changer itself, it was sort of twisting and not staying put in place. And what I found out after like taking I can insert some pictures here, I took this completely to the bone. There were these springs. Does anyone know what a Tellerfeder?
Spring washer, I guess.
Yeah, maybe spring washer. These were in here for the last 30 years, and those kind of lost their power, and the travel was being compressed. And that's why the it's called a Hirt profile, tooth profile. So basically there are two plates with teeth on it that interlock into each other, and those springs are pushing against this connection. And since the forces weren't high enough, it was separating a bit and allowed it for a bit of movement. So I changed out these springs, and I did only one test pass, but I cut a few raw stock, so maybe we can run this, and this will become like these bearing blocks here. So in terms of events, we're going to put it in like this, and then just your standard roughing type will face it and do the chamfer part. Then we're going to use a 60mm combination tool. You can here film this one for a second. This will do drilling. This will do drilling as well as turning. And then use a fine boring bar to get it to the tight tolerance.
The boring tolerance.
Yeah. So, and this is not properly Usually I would have already did the backside first, but I don't have those on hand. We'll see if that goes.
Do you get the files with this? Would be useful, I think.
Exactly, yeah.
Okay. Because I really like your
Yeah. That's. But
no, don't show
you say never touch a running system. It's been like this for 6 years, so no,
Yeah. Well,
it does work.
I mean, it's RS232, is it not?
this works. Refresh rate on the screen is amazing. I don't think this is the C problem. Yeah, that's because it's very close to screen. No, it's actually the screen. Yeah, you see that it's changing. Oh yeah, okay. It has googly eyes.
Okay, let me run this, and I changed a few parameters, so I hope this works out. So this is just your standard high speed, I think it's 8.5 millimeter drill. No center drill.
Can you pause it for a second?
Not now. Okay, so next tool is full drilling 16 millimeters. Let's see if that... That was the part where actually the tool changer was skipping, because there's a lot of inertia going down, torque going down that revolver.
You gonna buy this phone? Just bought a camera. That one. I must say the thing on those types of cameras, the view you actually get on the viewfinder is a lot lower quality than the actual footage.
Yeah.
Because there isn't enough processing power to show the actual footage at 1080p 60 fps.
Not too much I can do about it for now.
So after this we're gonna do one more and then just go upstairs, I guess? For the printer? We have the big mill left, yeah.
I just watched the mill as well. Pardon? You haven't looked at the small mill either?
No, but we have something planned for the large mill.
Oh, really?
Some electric tool
Generic stuff.
He just drew up a Linux line back
No need.
I'm gonna get roasted for this anyway.
Why?
Not for today.
Oh, the tube or
Yeah, because the cooling spray isn't even on the tap, so yeah, basically runs dry.
Yeah, you probably don't have to do that. All right, so we're standing in front of that's a Deckel Maho MH1200W. W is like for the tool changer. This has 1200 mil travel in X axis and 600 in Y and Z. And also you can swing away this whole tool head, and this has the horizontal and the vertical spindle, both accessible by the same tool changer. And I already set up some raw stock on here, which we're going to do just some arbitrary stuff on, just to get rid of some material and see the tool changer in action. And yeah, I already catted that up in Fusion. What I really like about these machines with Heidenhain control is the... Ah, you see, that is interesting. I mean, it was probably just the old instance. But these connect over LSV2 protocol. And then again, I can just go here, post-process these. Let's call that Shoptour. Just gonna go on the server. And this is real speed of getting these over. This is some adaptive toolpath. And it will do something like 6 kilobytes per second. Which is okay for that kind of machine. If you have like a real big 3D freeform finishing, I try to stay below like 2.5 to 3 megabytes of actual G-code, and that tends to like submit for 1.5 minutes or something of transmitting time. I think that's okay for me. I don't have to unplug and plug in USB drives or something. It just works out of the box with a serial connection on the computer, and it's been very reliable. Okay, so let's grab tool 1. This will take some time to reference the tool changer because it's just started up the machine.
Oh Gott. Das war auf einmal schnell. Ja, das ist auch ein teures Ding.
Okay, so according to Fusion, I have my work coordinates in the middle of the part. And Z0. Like face mill. So I mean, this is the raw stock. These 2 holes are already in here, so I just drew a spline around it. And then we're gonna face it with a face mill. Then there's some adaptive toolpath with a 60mm end mill that's gonna rough out, leave like 0.5 of a millimeter of allowance everywhere. Then it's gonna do helical entry in that hole, finish it at the same time, finish floor and finish the walls here. I think, yeah, it does finish the wall. And then it's just going to do some chamfering on here and here. So that's basically what we're going to do. I already submitted it. This light will start to flicker sometime. So of course.
Have any use?
Values. Ik heb dus op de wet niet geweten in mijn lijf. If you need, you can turn off float cooling. It's okay. Ja, wir können nur besser sehen. Ja, läuft doch ohne.
the power.
Can you guys still see?
In the microphone. I don't know.
It's like thinking about
I'm not gonna cry.
So this is what you would be doing for
Part of my day, yeah. It depends. Sometimes it's 1 day a week, sometimes it's 4 days.
No, it's cleaning the floor now.
Pardon?
It's cleaning the floor now.
Exactly. I mean, of course, it's not very efficient.
So this is basically what came out of it. There is no real programming went into this. It's just a showcase of some arbitrary like spline. And what's kind of interesting is these facets are coming because I chose like an adaptive toolpath to finish this outer wall, and this wasn't really you would have had to play around with a sophisticated finishing strategy as well as increasing the resolution on this. As you see, these on older machines, this is kind of the problem you run into with interpolation and size of G-code files, etc. So, but yeah, this was just with a dull end mill, just hawk away some material, drill a hole, and then yeah, just for showcase. Alright, so moving on to the upper floor. As I said before, down there is all about dust and grinding and chips, etc. We don't want to have that on the upper floor. This is about methodological processes. I'm having customers up here with working out on their industrial problems, etc. This is what I do for a main job up here. But this is also like been divided in 3D printing stuff, and then is electrical stuff, and then there's some miscellaneous things I've built over the years. Yeah, so we can just have like a quick look into all of that. Yeah, this is what I did call the Schwalbenhorst machine. It's basically like the eyrie of the bird's swallow, so direct translation. And basically this is one giant tool head, which is like 8.5 kilograms or something. This is all made of carbon fiber, and this is like brass for getting the different signals routed to all of these extruders. And basically you have two extruder motors that are pushing the filament into these melt zones, and in terms of melt zones, right now there are 18 on this machine. And those are all individually leveled to this glass plate, and in best case scenarios you would end up with 18 prints. The last time I ran this machine was like a few years ago, and then I finished 15 or 16 of those in just shy of an hour, so that boils down to, I don't know, 3 minutes 50 or something per benchy. The main difference is that this is even a quite good looking benchy for 2019 or 20 standards. And basically you could say, if you don't go, how long did this specific benchy go? It was about an hour, but in this kind of a footprint scenario, you could say this is each done in 3 minutes 50. This was not being accepted by the speedboat rules, which is okay, but it's just a very different approach to the problem. So of course, then you need like 18 rows of filament that are feeding in. This is done by these two steppers here that have a 10-to-1 gear reduction, and then basically just have these pusher assemblies stacked on top of each other. And there's a common shaft that is pushing all the materials in there. Since in 2018-19, there hasn't been like CAN bus adapters that adapt complete hot ends and fans and whatnot. This is like, it has a master hot end, and all of the others are built to very tight tolerances in terms of resistance, etc. So I'm always measuring the temperature of a single master hot end, and then this is feeding all the others with the same PID loop. Yeah, there's a video on this channel if you want to know more about this junk box of an electrical connection there. Yeah, then this is like the printers I've collected over the past years for various type of one-offs or production printing. I don't do production printing too much. This is basically most for prototyping, and I do have a number of printers also at home. That does make work in terms of how much can I use them time-wise. Got 2 times the X1 Carbon. I just explained early on that if at the time the MK4 Prusa would have been available, I would have chosen this one, but this was available at the time I needed those. This is one of the Formlabs Form 2. I bought this maybe 6 or 7 years ago, something in that neighborhood. And then there's 2 Prusa Minis. They actually do have a job right now. They do build one of my products, and as it turns out, the Prusa Minis, I get the best surface finish of all of these printers here. Maybe a combination of the Bowden drive or any other, I don't know, finicky parameters, but they do work best in terms of outer layer appearance. The MK3 is one of maybe the first printer I did order in off the shelf. This is at least 6, maybe 7 years old. This has just surpassed the 420 days of printing time. And yeah, exactly. And this has been going forever. I never did any maintenance on it. There were a few things that I was that were my fault, and then I had to do some maintenance. But from this printer itself, I never had to do anything about it. That's working really, really good. Next one is the Creality Print Mill. I think it's 030 or something called. I did a few things because I thought the technology was really interesting, but I think this machine has been in a state where it is pretty usable for production printing. But I got a lot of parts out of it. So for example, these belts are used in another machine here, and these are really cheap. I bought them as a replacement for the machine and used them in another project, and that worked out pretty fine. And then this is the Creality CR10 Max, which I use with I think it's 1mm nozzle on top for like the bigger prints. We can have a look at the TIE Fighter up there. This has been printed on this exact machine here. Let's go this way around. So yeah, as you can see, if you're here because you heard of the Minuteman machine, or yeah, I actually own 2 of these CMMs. This is the very first one I bought somewhere back in 2017, I guess. This has been my project for my bachelor's thesis, and what I did there was essentially planning to convert this CMM into a 3D printer of FDM technology. It is not what I planned in this thesis. It came different, but that's how it goes. And basically what I did is replace all the motion system with ball screws and servos. And this is basically on all 3 axes. Yeah, just changed. There's also like an 8-part series on YouTube where I do all the conversion. As you can see, here is this ball screw coming in. All these plates are glued on top of the granite. And then there's also back the X-axis with even a bigger servo. And then there's a whole switching cabinet built for it to run all these features. And since then it hasn't like had much use, but yeah, maybe we have some plans for the future regarding a combination of these 2, but we'll see. Yeah, so there are Another things you may find on YouTube or not. This is a project, I can't really tell you too much about it. This has been a robot for packaging industry. It moves in 3 axes, which is this one upwards, and this has a swivel mechanism to apply some sort of protection for glass items, I guess, but that's all I can say. Also, this is the TIE Fighter we built a few years back. You can see this is the plate of the people that were involved in this project. I don't want to hook the electricity up right now. There are a few cold spots on the soldering, but this thing has running lights, etc., and there are LEDs all over the weapon system, etc. But yeah, this has been hanging there since. And yeah, there is also a video about this sound system I built. This has got to be 21. This was my Corona project. I had a week of isolation and I thought, what should I do with that time? And this is basically old piping I found in my granddad's garage. They were covered in rust and concrete and whatnot. And then I decided to build a stereo speaker system out of it. So basically the upper part, these were 2 subwoofers, 8-inch, 20 centimeters in diameter, that are sitting in this 3D printed thingies here. And this whole thing builds or represents a volume of around 40 liters. And since it has this long tube, which is open to the ground, this is a bass reflex, how is it called? It's a resonated port. It's a ported enclosure tuned to around 40 hertz. So this has been helping these subwoofers to get a bit more into deep frequencies. And then there's a cutoff frequency at around 150 hertz, and then it's been taken over by these resonators here. And this is basically ceiling material that you get in office buildings that kind of absorb the frequencies or the sound waves. And since this is mostly done by by resonating and absorbing through motion, you can excite them pretty easily with the use of these small little exciters, which is basically just a speaker without the membrane. So this is the moving part, which is actuated by a voice coil, and you basically have them glued on the back of these things, and they do produce a very, let's call it, rich mid-range sound. So from 150 to maybe 15 kilohertz. And people often ask what is the sound like, and it's basically just the difference between listening to a CD or a vinyl. It just sounds different, or an analog to a tube amplifier or something. It is something completely different, and it works for a lot of things. It works really well, and for others I would prefer some standard loudspeakers. So especially acoustic songs and something is really unique to hear on the system, because with normal speakers you can find out where you can basically hear where the speakers are in the room. With these ones, this completely fades. You just have that big amplified area where sound is coming from, but you can't pinpoint it to the panels itself, and that's why it's so unique in the sound. I don't know if I want to answer that question.
What was the question?
How often do I play billiards? Yeah, okay, coming to the last unseen side, which you probably just have unfocused in some of these videos. I'm storing, let's call it, my dad's motorcycle here. He's not been living in Germany, and so he doesn't have a place to store it, and that's why I thought this would be a pretty cool place to have it. And yeah, then there's, let's call it, social rooms. This is a 9-foot tournament billiards table. It is, I think, a Belgian Gabriel type of thing. And yeah, the cloth should should have been replaced a few years ago, but since I'm wearing this out pretty evenly, it does work for me for like my lunch breaks or something, or whenever we have someone over at the evenings. So yeah, and as you might have seen or not, this is the Minuteman machine. It is sitting pretty much in the middle of all of this on the top floor. And yeah, there are a lot of people here that are all coming from the Discord server. And if you want to be part in, like, maybe we'll do this again as a shop tour, you should totally join the Discord server. There's also Jordi, the guy who's wielding the camera right now, is the admin of the server. He's here. Big thank you to Jordi at that moment. And, well, yeah. That has been like the shop tour of my company. I have no idea how long that is. If you have any questions, you can put that down in the comments. And maybe we'll cover that in the next episode or something. So, thank you for watching.